All right, this is section 3.5, part 4. Now we're talking about combining transformations. When combining vertical transformations written in the form a times f of x plus k, first vertical stretch by a and then a vertical shift by k. When combining horizontal transformations written in the form f of bx minus h, first horizontally shift by h and then horizontally stretch by 1 over b. When combined horizontal transformations written in the form f of b times x minus h, first horizontally stretch by 1 over b and then horizontally shift by h. Horizontal and vertical transformations are independent. It doesn't matter which or whether horizontal or vertical transformations are performed first. Okay? So if we have this, and f of x is equal to 2 raised to x, if g of x is the graph of f of x shifted to the left 3 units and up by 2 units, then write a formula for g of x. Okay, so g of x. Now, if we're going to shift to the left, remember that's going to be by the x value, and it's going to be positive because it's to the left. So this is going to be 2 raised to x plus 3, and then up by 2 units, so that will come down, so plus 2. Remember, shifting left or right, that only affects the x values, but shifting up or down, that affects the y values. So this would be your final answer for that one. Okay, let f of x be the square root of x. If g of x is the graph of f of x shifted to the right 1 unit, down by 4 units, and reflected about the x-axis, then write a formula for g of x. Okay, so g of x, number 1, we got shift to the right. Now we're going down, and we are reflected about the x-axis. Okay, and if we go back to reflection, if we reflect about the x-axis, so about the x-axis, we put a negative in front of the entire function. Okay, so let's do that. So we know we're going to have a negative in front of the entire function here. Now, let's deal with shift to the right 1 unit. So that's going to be inside, so that'll be x, and since it's to the right, minus 1. Okay, and then down 4 units, so minus 4. And that would be your formula. Now you can go ahead and distribute that negative 4, or sorry, that negative. That should be minus 4. Okay, that parentheses is a little far. It should be right there, just in front of that function right there. Okay, so now we've got it reflected about the x-axis, we've got it shifted to the right, and we got it down by 4 units. So this would be our final answer. Okay, describe the transformation. Okay, well, we know that it is absolute value, so the basic would be just a v. Notice how we have a negative 1, so we shifted to the right by 1, and then we went up 4, so 1, 2, 3, 4. So our graph should look like this right here. So the takeaway is we shifted, or actually let's just write this. We went to the right by 1 unit. We went up by 1. Sorry, by 4. We went up by 4. And that's it. Okay, describe this transformation. Now notice you could write this as the square root of x plus 2 plus 3. So we went up by 3 units, and we went to the left, because that's a positive, left by 2 units. Okay. Our main function here is x squared. So looks like we went to the left because it's positive, just like this one over here. So left by 1 unit, down by 5 units because it's a negative 5. And then looks like we've got a number right in front of the function. So we have, if we go back to our stretching and compressing, let's see, vertical stretching, compressing. Okay, a number in front of f of x. That number is greater than 1, so it looks like we have vertical stretching as well. So we'll say vertical stretch by 4 units, and that's what's going on there. Alright, this one we're going to have to change just a little bit. So we're going to write f of x is equal to the square root, and I'm going to pull the negative out, x minus 4. Okay, so now what we have is a negative by the x value. So if we go back to our reflections, okay, so x, or negative inside where the x is, so that's going to be a horizontal reflection, and it goes about the y-axis. Okay, so we got a horizontal reflection. Okay, so horizontal reflection, or you can say about the y-axis, either one. And also notice we have a negative 4, so we have shifted to the right, so the right by 4 units. Okay, looking at this one, looks like we've got number 1, we're down by 1 unit. And we have, so we've got a negative in front of the function, so that would be a vertical reflection. So we'll go back down here and write vertical reflection. And then we've got 3. So it looks like what we did over, let's see, here. Looks like it's a vertical stretch by 3. So we'll do vertical stretch by 3. And that's what's going on here. Okay, if we take a look at the transformation of the square root of x, we need to write a formula for it. We know the original function starts at 0 and goes like this right here. So what we have done is we've moved over to the right by 1, 2, 3, 4 units and up 1, 2, 3 units. Okay, so let's deal with to the right. So that would be y is equal to the square root of x minus 4, because we went 4 to the right, and then we went up 3, so plus 3. So that would be our formula for this transformation of the graph. Okay, for this one, x squared, we know it starts at 0 and it goes up like this. Something like this. Okay, so what we have done is we've moved over to the left, it looks like 1 unit, and then we've gone 1, 2, 3 up. Okay, so we've got y is equal to x plus 1, whole thing squared, plus 3. And that would be our answer. Okay, this function here, let me show you the original function. Looks like this on either side of the y-axis. They are going up, but they don't ever cross the y-axis because you can't plug in 0 into this function because the entire fraction would be undefined. And remember, it's going up. Ours looks like it was going downward, so it flipped over the x-axis. So let's get back to where we were. Right here. Okay, so it flipped over the x-axis. And also notice you've got an asymptote at 2. So it looks like it scooted over to the right by 2 units. And also, let's go back and look at it again. The original function right here. It looks like the x-axis is also an asymptote for that one as well. Okay, so we can go ahead and write y is equal to negative 1 over, and we said that it moved to the right 2 units, so x minus 2, whole thing squared. And then notice there's not an asymptote for the x-axis anymore. Looks like it shifted down to negative 1, so it shifted down, or minus 1. So this would be our formula for that transformation. Okay, the original x raised to 3 or x cubed, we know it starts somewhere right in here. Okay, so it's starting at 0, this little change between this right here. So it starts at 0. It looks like it's moved over. So this is the point I'm talking about. 5 units. Let's see, 1, 2, 3, 4, 5 units to the left, and then it's gone 1, 2 up. Okay, so we've gone to the left, so we've got y is equal to x plus 5 cubed, and then plus 2. And that would be our transformation formula. Okay, this one, same thing. Looks like, now we know it has this shape right here. Looks like this one has the opposite shape. And then it's moved, this little part right here has moved 1, 2, 3, 4, 5, and up 2. Okay, so it looks like now it's gone to the right by 5 units and up 2, but then it has changed its shape. Looks like looks like they're a mirror image of each other, close to it if we shifted it up. So that would be about the y-axis here. Okay, so we need to be careful writing this. So we've got negative this entire function in here. So x, and it went to the right, so this would be negative 5. This whole thing cubed, and then plus 2, and I'm going to distribute that negative inside. So this would be negative x plus 5 cubed plus 2. So this would be our equation for this transformation. And then let's look at this one, the absolute value of x. We know the absolute value of x starts right here at 0. Looks like we've moved over 1, 2, 3, 4 units, and then down 1, 2, 3 units, okay? So y is equal to the absolute value. Now we went to the left, so this is going to be x plus 4. And then we went down, so minus 3. And that would be our equation for this transformation.